Now, let's say here we have a file. The file that we're working on is just a simple file, a grocery list, okay? So you have a file, okay? And this file has, you entered milk in it, okay? And when you initiate the repository, the .get directory will be created. At this moment is empty, okay? You can have a file, we'll have another file in your directory. It's called .get ignore. So these are the list of files that you don't want to be kept in the local repository. So this is just files that you don't want to keep revisions of. You don't want to keep the history of these files. So you list them, their names in the .get ignore. Okay, so when you initiate a repository, the directory .get directory will be created, and also a file named .get ignore will be created that should contain the lists of any files that you don't want to keep the history of. Okay, now I have a file now I just created. It's the repository is still empty. I didn't commit it. I didn't keep track of any history of it. So what do I need to do? I need first, when you have a file after initiating the repository, if you are working integrating Git in your IDE, it will be highlighted with a red color generally. So I've seen this in different IDEs. I don't claim that I tested every single IDE that exists, but I've seen these colors consistent in a couple of IDEs. Okay, so generally it highlights a file that is not uh, a new file that should be added as red. If it's not inside, if it's not listed in the git ignore and it's not added to the repository, it will be highlighted as red, just to indicate that this file needs to be added to the repository. Okay, so when you issue the command add, either command line or through the IDE, it will turn green because there is it will be added to the staging area. So it's not in the local repository yet. It's in the staging area. Okay, so only when you issue the command commit that a copy of that file will be added to the repository, and it will be given a unique ID. Here for simplicity we call it R1, but when you look at the actual revision ID, it's a set of characters, unique set of characters, so it's a longer name for the ID. Here for simplicity we say R1. Okay, now you can skip this staging area thing. If you don't have to say add and then commit, you can just say commit -a. It means that you can skip the staging area. You just, any file that is not added to the repository, commit it directly. You don't have to put it in the staging area. All right, so now we did one commit, so we have one revision, and then later we made another change. So the color of the file will also again change to green because it is added to the repository. The repository, so Git is keeping track of it, but at this moment there is a change that you didn't commit yet. So when you say commit, another copy of the file will be added to the repo, and it will be given in another unique name. Here we refer to it with R2. In addition to that, the differences between R1 and R2 are also kept track of. So Git will know, will have a copy of R1 and another copy of the file that is R2, and then the differences between the two. So that's how it toggles between the revisions. So if you want to go back from R2, you want to go back to R1, it knows what to do to toggle between the revisions. Okay. Now I had another change here. Like, as long as you keep making changes, it keeps copies of the revisions, give each revision a unique name, and keep track of the changes between the revisions. Okay, so that structure inside the repo, it looks like a tree structure or a branch-like structure. Since we have only one branch, it would be called the master branch. Okay, so here, this is the revision, and then how to go from one revision to the other. So that's connection between the revision. So that looks like a branch. It's called a master branch. All right. Okay, now all that happening in the local station. Nobody else can see that. So all that in your local repository. So if you want other people to see your, oh, sorry, before we go to the remote thing, you can revert to any other revision. So let's go back one step here. So we had changes, we had created revisions, second revision, and then we made a list of other changes. We have a branch. Okay, now we can look at all these revisions and let's say revert to one of them. Let's say we wanted to revert to R2. So what happened is that this copy, they will take a copy of this revision and overwrite the working file. So that would be considered as a change in the working file. Okay. Now we didn't lose R3 and R4. R3 and R4 are still there in the history. Okay. When you get to commit that, it will create another revision. So let's say this is going to be R5, and it will calculate the difference between the latest revision and the one that you just committed. Okay, so he didn't lose any history here. When you revert, so reverted to R2, and then when we commit, a new revision will be created. Okay, and the differences between the latest revision and that new revision will be also calculated and kept track of in Git. All right, now all that is happening local. Nobody else can see it because we are committing to the local repository. Or if you want other people to see it, you have to push your changes to the remote repository. So for example, if you have a repository on GitHub, you have to push it to that remote repository. Okay, so what happens is that a copy of the entire history will be created on the remote repository. Now, when someone else wants to see the changes, when someone else wants to see the changes, so this is a workstation of another person. They would need to fetch or clone that repository. So what will happen is that it will copy the repository into their local repository. And then when they check out, they will get the latest version copied into their working directory. All right. So you can all keep working like this, making changes. Changes kept track in the local repository, and when you feel safe about it, you can push it to the remote repository, and then other people can update their own local repository by fetching, okay, and so on. Okay, so now we have what we described, we only had one branch. Since we had one branch, it's called the master branch. You can create other branches to make side changes before you decide when to merge them to the other branch, to the master branch. Okay, so Git allows you to do that. Generally, you can use a branch for development and then another branch for release. Okay, so, and if you have specific features, you can have a branch for individual features, or if you have a bug, you can have a branch for every bug. You can also use branching to have branches for each team member. So each team member can have their own branch to do their changes. As long as at the end you have to merge them correctly, and there might be some conflicts that need to be resolved before the merge happens. Okay, so this is the general concept of Git in version control. I also posted a link to a tutorial for GitHub. You may find it useful if you need to. Okay, so let me know if you have any questions.